सब्सक्राइब कीजिए हमारे चैनल फिजिक्स विद कौर को और बेल आइकन को दबाइए लेटेस्ट एजुकेशनल वीडियो को सबसे पहले देखने के लिए।
Hello everyone, I hope all are doing well and happy new year. In the last lecture, we have discussed about the high pass filter and its limitations. But in today's class, we will be going to discuss the low pass filter, plus the limitations will remain the same, what we have suffered for the high pass filter and what we have done to overcome that limitation. That what we have used the op-amp. What we will be using op-amp, that is operational amplifier. Fine, so first of all I just discuss more about what is low pass filter. हम थोड़ा जल्दी डिस्कस करेंगे कि एक्चुअली में लो पास फिल्टर होता क्या है, what is circuits look like, because everything will remain just the same as what we have discussed in the high pass filter. So what we required a resistance. In this case you will be having a resistance in the series and हमारे पास हमें जो अब वोल्टेज ड्रॉप लेनी होगी वो हमें लेनी होगी कैपेसिटेंस के अबाउट. अब हमें क्या लेना होगा, कैपेसिटेंस के अबाउट उसकी वोल्टेज ड्रॉप लेनी होगी. and we have given a supply that is Vi, positive, negative, and I'm taking the output across the capacitance. Again we will apply an voltage divider rule. What we will get AV. What is AV? That is your gain, that is V0 upon Vi. If you have not watched my lecture 3, you just you will get in the description box, description link below. You will get the link in the description. And what will get V0? You have to find the voltage across C. Okay. So now what is the reactance? That is XC 1 upon J omega C. Now just put the value here. You will get 1 upon J omega C upon R plus 1 upon J omega C. Now what I can take, I can simply take an LCM, and so what I'll get 1 upon 1 plus J omega R C. This is what I'll get after the simplification. Now I'll just take the mod of it. I'll get mod as AV mod. That will give me 1 upon 1 plus omega square R square and C square. This is your gain. And what is the phi? Phi is nothing, that is tan inverse Y by X. What is Y? Omega RC upon 1. So this is your phi. Now your phi will be negative because already we have discussed in lecture when there is 1 plus J omega RC, then you will get phi is negative. It's a concept of a complex, so the phi is negative. That means it is a lagging circuit. Phi is negative indicates that it is a lagging circuit. It is a lagging circuit. Okay. So the same way what we have done in the previous lecture, we have plotted the graphs and we have interrupt from the graphs. What we get from the graphs, we will see to it. Again, what is the need of high pass and low pass filter? High pass filter is nothing that allows low frequency to pass easily, and what high pass filter do? High pass filters allow the high frequency to pass easily and blocks the low frequency. That is just indicates by its name only. Now we can plot the graph, that is omega, we have AV, and we have phi. We can take 0. Next is 1 upon RC I can take at, and infinity. Again we will get gain as 1 by root 2. You can just put the values in the formula just we have discussed right now. 0, minus 45 degree and minus 90 degree. Now if I plot the graphs between the gain and the omega, what I'll get, I will just plot AV here and omega here. So I'll get that this is 0, this is 1 by root 2, and this is 1. Okay, and just plot 1 by root 2 pe you are getting a value as on 1 upon RC, right? 1 pe 0, it's infinity, you are getting again as 0. Fine means at high frequency you're getting again as 0. and at 1, when AV is 1, that is your gain is 1, your omega is 0. So just for the graph, it will look just like that. Okay, just trace it properly. And the next is the phi one. You can refer the book, that is Gaekwad, for the op-amp and operational amplifier. And I'm making in the negative direction. This is omega, this is, and you are getting a graph like this. 1 upon RC with something here, and here is you're getting a minus 45 degree that you, yeah, that is the value of 1 by root 2 basically. So you will get your graph like something like that. I just put here, dot it, so it will look like something like that. So I'm making in the negative direction because my phi is negative. My phi is negative, right? This is my phi around y-axis. So it is in a negative direction of phi, and there you having a omega. Now, what else? What else we have to discuss in this? Now, what we have switched to? We have switched to, oh, this is what we have discussed about the low pass filter, and what we have already discussed the limitations. This is the same limitations. अगर मैं C के साथ कोई लोड लगा दूँ तो वो C के साथ क्या आ जाएगा, पैरेलल में आ जाएगा. अगर मैं इधर जाती हूँ, just be good. अगर मैं इसके साथ कोई यहाँ पे एक रेजिस्टेंस लगा देती हूँ तो ऑब्वियसली इट विल इफेक्ट माय गेन, मेरे गेन को इफेक्ट करेगा, प्लस मेरी कट ऑफ फ्रीक्वेंसी को भी इफेक्ट करेगा. ठीक है, अब मैं अपने आउटपुट को इफेक्ट, मैं अपने गेन को इफेक्ट नहीं करना चाहती हूँ. व्हाट आई हैव नीडेड, आई हैव यूज्ड ऑपरेशनल एम्पलीफायर विद द नेगेटिव फीडबैक. मतलब मैंने ऑपरेशनल एम्पलीफायर को यूज किया है टू रिजॉल्व दिस प्रॉब्लम. आई हैव यूज्ड अ वोल्टेज फॉलोअर. और व्हाट इज एक्चुअली अ वोल्टेज फॉलोअर? दिस इज योर op amp. This is negative, this is positive, and I have given a supply here, that is Vs, right? This is your N, this is your P, और मैंने नेगेटिव से आपका आउटपुट दिया है. ठीक है, that is your V naught. I'm just taking a right now an ideal case. I'm discussing here an ideal case. What is an ideal case? Consists of a practical, you can say ideal op amp. Here it says the properties are Rn is equals to infinity, Rf is equals to 0, your open loop gain, that is equals to infinity, your CMR ratio, that is also equals to infinity, your bandwidth is equals to infinity, that means it allows all the frequency from minus infinity to plus infinity. Its slew rate is also infinity. So these are the properties of an ideal op amp. These are the properties of an ideal op amp. Properties of ideal op amp. Now we have given a negative feedback where I have taken RF is equal to 0 because I'm just discussing about the ideal. And here what we will using on a concept of a virtual ground. Virtual ground means the potential that being provided at P will be reflected here at N. In some another lecture I will be discussing about more detail about virtual ground or virtual short. ठीक है, तो मैं आपको किसी और लेक्चर में बहुत अच्छे से समझा दूंगी. बट राइट नाउ जस्ट अंडरस्टैंड दैट कि आपके पास वर्चुअल शॉर्ट क्या होता है. जो भी आपने पी पे सप्लाई दी होगी, जो आपके पास पी पे पोटेंशियल होगी, वही आपके पास एन पर होगी. दैट मीन्स अ नेगेटिव, दैट इज योर इन्वर्टिंग वन. सो हमने यहाँ पे क्या दिया, नेगेटिव फीडबैक दी. तो जो आपके पास वर्चुअल कॉन्सेप्ट का जो कंसेप्ट होता है वो भी आपके खाली नेगेटिव फीडबैक में ही यूज होता है. सो नाउ दैट इज here you will be having a gain is of 1. आपके पास जो AVS होता है for the ideal is 1 because your open loop is infinity. So AVS is 1, that is your closed loop. When you have applied feedback, you will get that gain as 1. And here phi is equal to 0 degree. मतलब आपके पास कोई भी phase difference आपको provide नहीं कर रहा. ठीक है, आपके पास कोई भी phase difference आपको provide नहीं कर रहा. तो after using an op amp, how my circles will exactly look like, we'll see to it. कि हमने जब सर्किट ये अब हमने लगा दिया तो वहां पर सब सर्किट कैसे दिखेंगे. आई एम यूजिंग एन हाई पास फिल्टर. ठीक है, जिसको हम कहते हैं फर्स्ट ऑर्डर बटरवर्थ फिल्टर. ऑल्सो हम इसको ये भी कहते हैं फर्स्ट ऑर्डर बटरवर्थ फिल्टर। ठीक है, अब हमने क्या किया, अगर हाई पास के लिए यूज करना है तो हमने क्या किया, दिस इज योर capacitance, this is your resistance R, this is Vs attached to the op amp, आपने op amp लिया, this is a positive, negative and this is your feedback. अब आप एक चीज नोटिस करो, this is for high pass, ठीक है, this is your high pass filter using op amp. Now everything will remain the same, the gain and everything will remain the same. What has been changed? अब आप यहाँ पे कुछ भी लोड लगा दो, मेन चीज आपको ये समझनी है कि अब आप यहाँ पे कोई भी लोड लगा दो, उस लोड से आपके आउटपुट पर कुछ फर्क नहीं आएगा। या हमने लोड लिया तो इसके आपके आउटपुट पे कोई फर्क नहीं आएगा, जबकि हमारे प्रीवियस केस में हमारे आउटपुट पर फर्क आ रहा था, प्लस हमारी कट ऑफ फ्रिक्वेंसी में भी चेंजेस आ रहे थे। व्हाट इज एक्चुअली योर कट ऑफ फ्रिक्वेंसी? FC इज इक्वल्स टू 1/2 बाय RC। जब हमने इसके अक्रॉस, जब हमने पिछले वाले केस में इसके अक्रॉस लोड लगाया था तो हमारे पास ये जो R था वो R' में चेंज हो रहा था। अब आप यहाँ पे लोड लगाओगे तो उससे आपके पास आउटपुट पर कोई भी फर्क नहीं आएगा। So this is the use of using an op amp. Fine, and I'm just making here another diagram, that is your low pass filter or first order Butterworth low pass filter. This is your high pass filter, first order Butterworth high pass filter. So I'm writing here high pass. Okay, and for the low pass, that is your first order Butterworth low pass filter. So what is that? आपने अब लो पास का हमें सर्किट पर होना चाहिए. This is R, this is your C, this is your ground. Sorry, this we need a ground here. This is your ground. This is C, this is your R, this is your VS, this is a op amp, positive, negative से हमने आपका दिया negative feedback, and this is your V out. So everything will remain the same, the gain and everything, okay, and the maximum gain that you can achieve is A is equals to 1. So this is what is actually your high pass and low pass filter using an op amp. This is your first order Butterworth. Okay, this is your first order Butterworth. There also are second order Butterworth and third order Butterworth, but second order Butterworth filter और थर्ड ऑर्डर बटरवर्थ फिल्टर में आपके पास चीज़ें ज़्यादा लगती हैं, प्लस आपके पास बेटर तो होता है इंस्ट्रूमेंट, बट आपके पास एक्सपेंसिव हो जाता है बिकॉज मोर ऑफ द थिंग्स विल बी बीइंग इनटू योर सर्किट्स. Okay, so this is your first order Butterworth low pass filter. So thank you so much. If you like this if you like today's lecture, please share, subscribe, and thank you so much.